All right, good morning, guys. So today we're going to we're going to second day of absolute value functions, but today we're doing a little more complicated stuff, which is graphing absolute value functions. So pause me whenever you want, copy this down, these are good notes, and I'll explain what this means in just a minute. This first one says y equals the absolute value of x. This is considered the parent function, or the parent graph, because all the other graphs that we make inside this concept come from this exact thing. I'll show you what I mean in just a minute. The shapes of every single absolute value graph is either a right side, a correct facing up V, or a facing down V. And it's a V, not a U. And when we get the quadratics later on, you'll see the difference between why this one is a sharp V, either upside down, or right side up. The other situation here is when figuring out how to graph these functions, try to use point testers. Point testers, I'm using language you guys are familiar with. You would have learned that last year in Mr. Miken's class when you learn how to graph stuff for the sake of learning how to graph on the coordinate plane. Use point testers to make the inside of the function equal to 0. So I'll be back in a second to show you what all this means. Pause me when necessary. All right, I'll graph this first function, and I'll show you how to do this. Okay, your point testers. You're going to see after doing enough of these, you're going to see what the point of all this is. You got to make point testers. Now this one's rather simple, and you'll see eventually there's a quicker way to do it. But I need you guys to understand the concept. What makes the inside of this 0? Well, 0 does, obviously. So the way you do this now is I go 2 above 0, 2 below 0 to create my window of numbers. So I'm going to go from -2 to +2, and that's going to be good enough. This is how I've always taught it in the beginning, and eventually we'll learn a easier method. But again, I need this concept understood. So when I put -2 in place of x, the absolute value of -2 is 2. When I put -1 in place of x, the absolute value of -1 is 1. Well, 0. When I put 1 in place of this, the absolute value of 1 is 1. When I put 2 in there, the absolute value of 2 is 2. Now I graph this. Okay? Here's the graph. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. -2, 2. Right there. -1, 1. 0, 0. 1, 1. 2, 2. I have created the basic shape of this basic graph. Now that one was easy because this is all it said there. Now let's do another one. Say I did one like this. Let's say I did y equals the absolute value of x minus 3. Okay? So now again, your thinking is, what makes the inside of this 0? It's the basic function of what you do. If I replace x with 3, 3 minus 3 is 0, so 3 is my baseline, right? So I go 3 above 3. I go 2 above 3 and 2 below 3 to create my window. So 2 below 3 is 1, 2, 3, 4, 5. This will always help you guys create your V. This is how you always do it. So now 1 minus 3 is -2. Absolute value of -2 is 2. 2 minus 3 is -1. Absolute value of -1 is 1. 3 minus 3 is 0, so that's 0. 4 minus 3 is 1. Absolute value of 1 is 1. And 5 minus 3 is 2. Absolute value of 2 is 2. Do you see how I have some symmetry here? I got 2, 1, 0, 1, 2. I got the symmetry there. Symmetry there. So now let's graph this. Okay? Now I have enough information to graph my stuff. I'm going to go 1, 2, 3, 4, 5. Sorry, I did not make this big enough. Is what it is. 1, 2, 3. So when x is 5, y is 2. X is 4, y is 1. 3, 0. 1 here, 1 there. This is all you gotta do every time you're graphing these puppies. Okay? Let's do some more. Pause me, do what you gotta do. Let's do one like this. Let's do y equals, let's say we got one like this. Let's say I got x plus 2 minus 3 on the outside. You might see something like this. Don't worry about this right now, alright? Now we have to do this again. What makes the inside of this 0? -2 does. So, 2 above -2, 2 below -2. I'm going to go from -4 down to 0. -1 and 0. Do the math. -4 plus 2 is -2. Absolute value of -2 is 2. 2 minus 3 is -1. -3 plus 2 is -1. Absolute value of -1 is 1. 1 minus 3 is -2. This is 0. -2 is 0. 0 minus 3 is going to be -3. And -1 plus 2 is 1. Absolute value of 1 is 1. 1 minus 3 is -2. Look at this. I already know this answer to be -1 just based on the symmetry. Let's see to make sure I got my desired shape. 1, 2, 3, 4. 1, 2, 3, 1, 2. Doesn't matter because you already know it's resist over here. -4 is at -1. Okay. -3 is at -2. And -2 is at -3. -1 is at -2. And 0 is at -1. That's all you got to do. See how that works? Now I want to do one more. Give me 1 second. Okay. This will be my last example for the day. But let's see this one. What's different about this one is now all the other ones I showed you did not have a negative sign on the outside. So now, because of this, everything that comes outside of the absolute value will now be negative because this says take the opposite of whatever this produces. So your same thinking has to apply here. All right. Oops, not 5. Duh. Y. So what makes inside negative? I'm sorry, 0, -5. So I'm going to do -7, -6, -5, -4, -3. Let's do our work. -7 plus 5 is -2. Absolute value of -2 is 2. The opposite of 2 is -2. -2 plus 3 is 1. -6 plus 5 is -1. Absolute value of -1 is 1. Take the opposite of 1, which is -1, plus 3, which is 2. Duh. 0. The opposite is 0, 0. 0 plus 3 is 3. And I hope my symmetry is going to work here. -4 plus 5 is 1. Absolute value of 1 is 1. Opposite of 1 is -1 plus 3 is 2. We already know this will work out too. Okay? So now let's just graph this puppy. No, let's make this a little easier. Seven. 1, 2, 3. 7 is at 1. 7 is at 1. -6 is at 2. -5 is at 3. -4 is at 2. And -3 is at 1. And that is when we're going to have it upside down facing absolute value when we see this negative guy on the outside. So you're going to see a lot of these examples today. Make sure you're asking questions. I'll see you guys in class.